Start minute. Start minute.
Good afternoon, students. Yesterday we have discussed what are the half planes, how the points are how a straight line divides a set of points. We have discussed how the set of points lie on the line or one side of the line and on the other side of the line. Also, we have seen if two lines are parallel and if a third line is parallel, then how to prove the conditions of the parallel also. Now we are going to see if there is a line lambda 1 L1 plus lambda 2 L2 is equal to 0. If this line represents L1 is equal to 0, then lambda 2 is equal to 0. If L2 is equal to 0, this implies that lambda 1 is equal to 0. Lambda 1 is equal to 0. If there are two lines, let's say L1 and L2, and there is a point of intersection of these two lines, there is a line passing through this point of intersection. The equation for this line we can write in the form of L1 plus lambda L2 is equal to 0, where lambda is not equal to 0 and L2 plus mu L1 is equal to 0, where mu is not equal to 0, So these are the things we can write. Okay, let us see a problem. Regarding this, how to find the point of intersection. Okay, equation of a straight line. Example, find the equation of a straight line passing through a point of intersection of the line x plus y plus 1. They have given two lines, that is L1 is equal to what? X plus y plus 1 and L2 is equal to 2x minus y plus 5. 2x minus y plus 5. And what about the line? The line contains this line we need to find a line such that it contains the given line. We have already discussed that if there are two lines, here they have given the line 1, that is equal x plus y plus 1, and line 2, 2x minus y plus 5. This is the point of intersection, and the other line is passing through this point of intersection and contains a point. If a line is passing through the point of intersection of these two lines, then the line will be of this form. The line passing through the point of intersection of L1 and L2 is equal to, it will take the form L1 plus lambda L2. Therefore, I am writing the equation in this form, that is, here what I have L1. Therefore, the equation, the required equation is what? That is x plus y plus 1 plus lambda into 2x minus y plus 5 is equal to 0. Then what can we do? That is, and what they are saying more, that it is passing through a point. The required line is passing through a point 5 comma minus 2. It is passing through a point 5 comma minus 2. It is not lying on any of L1 or L2, but it is passing through this line. By hypothesis, hypothesis, what can we do? This line is passing through this point. As this point is passing through this line, so we are substituting in place of x and y. We are substituting 5 comma minus 2 in the required line. Therefore, this implies what? 5. In place of y, I have a minus 2. Plus of minus will be minus 5 minus 2. 5 minus 2 plus 1 plus lambda into what we have? 2 times of x. 2 times of 5 is 10. Minus, here I have minus 2. Minus of minus will become plus. Plus 2 plus 5 is equal to 0. Is equal to 0. Then how much I'll get? 4 plus 5 minus 2 is 3. 3 plus 1 is 4. Plus lambda into 10 plus 2. 12 plus 5, 17 is equal to 0. From this we are able to find what? Lambda. Lambda is equal to minus 4 by 17. Minus 4 by 17. Then substituting in the given line. Now substituting in the required line. Now substituting the lambda value in the required line. So that we'll get the equation of the required line. Therefore, the equation of required straight line is so x plus y plus 1 plus what is the lambda? Minus 4 by 17 into 2x minus y plus 5 is equal to 0. Is equal to 0. Now I am taking this 17. That is, I am taking the LCM of the denominators. That is 17 into x plus y plus 1 plus or minus is minus 4 of 2x minus y plus 5. 17 will be in the denominator, but if it goes to the other side, it will become 0 into 17 is 0. Hence, I am writing 0 there. Then what will get? 17x. If 17 is multiplied inside, then 17 times of x is 17x. 17 times of y is 17y plus 17. Plus of minus is minus. 4 times of 2 is 8x. Minus of minus is plus 4y. Minus of plus is minus 20 is equal to 0. That is what here I have x 17x minus 8x is equal to how much I'll get? That is 9x, 17y, 4y plus 21y plus 17 minus 20 is minus 3 is equal to 0. If I take 3 common from this, what I'll get? 3x plus 7y minus 1 is equal to 0. This is my required equation. This is my required equation. What they have given, just we will have a look. They have given the lines L1 and L2 and they have said that find the equation of the line which is passing through the point of intersection of these two lines, as well as it contains a point 5 comma minus 2. It contains a point 5 comma minus 2. We know the line which will be passing through the two given lines will be of the form L1 plus lambda L2. So we are taking and we are substituting, as this line is of the form this, we are substituting the point and we are getting the lambda value. After we will find the lambda, what we'll do, we will substitute the same thing in the required line, what we have taken, required equation, what we have taken. Then we'll get the required equation of a straight line. Then we will get the required equation of a straight line. Okay. Next one. So what about the points of concurrence if we have 3 lines? The point of concurrence will be for 3 lines or more than 3 lines. But here we are taking the 3 lines and we are proving how to find. What they have given, we have a theorem, that is concurrent line. Here L1, they have given a line L1. L1 is A1x plus B1y plus C1 is equals to 0 and L2 is equals to A2x plus B2y plus C2 is equals to 0 and L3, they have given L3. L3 is equals to what? A3x plus B3y plus C3 is equals to 0. Is equals to 0. So, what they are asking us to prove? They are asking us to prove the point of, that is, these three lines are given, L1, L2 and L3 are given. This they are asking us to prove. That is the point of concurrence. Point of concurrence. Already we know if two lines are given. Already we know if the two lines are given, then what is the point of intersection? Therefore, for the lines L1 and L2, point of intersection is equals to point of intersection. Point of intersection is how much? Is equals to B1 C2 minus B2 C1 by A1 B2 minus B2 B1 A2, and here C1 A2 minus C2 A1 by A1 B2 minus B1 A2. Okay, this is the point of intersection if two lines are given. That is the point of intersection of two lines. But here they are asking point of intersection of three lines. As we know, this third line is also passing through this point. So I am substituting in the line 3, that is in the equation of the line of 3, I am substituting this point. Therefore, as L3 is passing through the point of intersection of L1 and L2. So what we are doing? We are substituting this point in this equation. That is A3 into, what is X over here? That is B1 C3 minus B1 C2 minus B2 C1 by A1 B2 minus A2 B1 plus, what is plus D3 into, what is Y over here? Y is this one. That is what is Y? Y is C1. Y is C1 A2 minus A1 C2 by A1 B2 minus A2 B1 plus what we have? Plus C3 is equal to 0. So this is equal to how much? Here we have the denominator same. So I am taking the LCM and sending that to the other side. So here what I'll get? A3 into B1 C2 minus B2 C1 plus B3 into C1 A2 minus A1 C2 plus C3 into A1 B2 minus A2 B1 is equal to 0. Now I am multiplying this inside. A3 B1 C2 minus A3 B2 C1 plus B3 C1 A2 minus A1 B3 C2 plus A1 B2 C3 minus A2 B1 C3. So, sum these two, I am taking A1 common. if I take A1 common, what I'll get? B2 C3 minus C2 B3. Next, if I take B1 common from these two terms, what I'll get? If I take B1, then what will get? A3 C2 C2 A3 minus C3 A2 plus if I take C1 common from the remaining two terms, what will get? B2 A3 minus B3 A2. Hence, we can say that this is the point of concurrence. If three lines are given, this is the formula to find the point of concurrence. This is the formula to find the point of concurrence if three lines are given. If three lines are given, this is the way we will. That it can be represented as sigma of A1 into B2 C3 minus C2 B3. B2 C3 minus B2 C3 minus C2 B3 A1 into. So what we have done, just we'll go to, they have given three lines. We will find the point of intersection of any first two lines. We have taken the point, we know the point of intersection of two lines. So this is the formula we had point for the point of intersection of two lines. And after that, what we are doing, as the line LT is passing to the point of intersection of the two lines, we are substituting that point of intersection in the third line. And we are getting the point of concurrence. Next, we have problem, that is, find the value of k if the lines 2x minus 3y plus k equals to 0, 3x. They have given three lines and they are asking us, and they have given the condition that they are concurrent. They have also said that they are concurrent lines, and what they are asking us to prove, they are asking us to prove the value of k. They are asking us to prove the value of k. So we have taken the two lines, we have taken the we have to take the three lines, that is 2x minus 3y plus k is equals to 0, 3x minus 4y minus 13 equals to 0, and 8x minus 11y minus 33 is equals to 0. They have given this, these lines are concurrent. Let it be equation 1, 2 and equation 3. Where is k? K is in equation 1. Where is the unknown value? The unknown value is in equation 1. The unknown value is in equation 1. The unknown value is in equation 1. So if we already they have said that these are concurrent, these lines are concurrent. So we need to solve these two, equation 1 and equation 2 and equation 3, so that we can find the x and y values, After finding x and y values, we need to substitute that in equation 1 as that line is also passing to the point of intersection of these two lines, and we'll get the value of k. So solving equation 2 and 3. We are solving equations 2 and 3. So what I'll get? X by the rule of cross multiplication. By the rule of cross multiplication, we are solving these two equations, that is x, y and 1, to get the value of x, y. So take first y coefficients of y, then c, then a, then b again. So we'll get x is equals to what? Minus 4 into 33 times of 4. How much will get? 132. How? Which 32 minus of minus will become plus? We will get 132. Minus of minus will be plus. Plus of minus. Here we have minus of minus of this is 143 by 3 times of minus 11 is minus 33. Minus of minus will become plus 32 plus 8 fours are 32. Now y, how can we find y? This into this, that is minus 13 into 8, minus 13 into 8. How much will get? That is minus 104 and minus of minus will become plus. The 33 is how much? 99 by what we will get the same thing, that is this in minus that. That is 3 times of minus 11 is minus 33. Minus of minus will become plus. 8 fours are 32. 8 fours are 32. So what we are getting the point of intersection, that is x is equal to how much we are getting? Minus 11. X is equal to 143 minus 132 is minus 11 by minus 1. Minus 7 by minus 1, which is 11. And what is y? Y is equal to minus 5 by minus 1. Then what we will get? We will get it as a 5. We will get it as a 5. Therefore, the point of intersection of these two lines is what? 11, 5. Therefore, point of intersection of L1 and L2 is what? 11, 5. As L3 is passing through 11, 5. So this implies what? 2 times of 11 minus 3 times of 5 plus k is equal to 0. Plus k is equal to 0. This implies what? 22 minus 15 plus k is equal to 0. That is 22 minus 15 is how much? 7 plus k is equal to 0. This implies what? K is equal to minus 7. K is equal to how much? Minus 7. How to find the values? How to find? Let it be L3, this will be L1 and this will be L2. This is L2. Now we are solving. What they are asking us, find the value of k. To find the value, that is the unknown value given in the equation. First we need to solve the equation 2 and equation 3 first to get the point of intersection. After getting the point of intersection, we need to substitute that value in the that is the L3 will get the value k. That is the unknown value. That is unknown value. So this is how we will find the value of k if 3 lines are concurrent. If they'll specify that the 3 lines are concurrent and in the one of the line they'll give the unknown value k. Next, if the straight line they have given the 3 lines, that is ax plus by plus c is equal to 0 and bx plus cy plus a is equal to 0. Next is cx plus ay plus b is equal to 0. They have given, if the straight lines are concurrent, they have given that this line 1, L1, L2 and L3. What they have given? L1, L2, L3 are concurrent. Then what we need to prove? We require to prove that a cube plus b cube plus c cube is equal to 3abc is equal to how much? 3abc. BC. So first what we need to do, we need to solve this equations. Solving, it will be 1, 2 and 3. Solving equation 1 and 2. What will get? X, Y and 1. So first BC, CA, AB and again BC. Then X is equal to how much? This into this minus this into this. That is AB minus C square by this one. By what? By this. AC minus B square. AC minus B square. And Y is equal to how much? Y is equal to BC minus A square. BC minus A into A is A square by AC minus B square. We got the point, that is the intersection, point of intersection from these two equations, that is equation 1 and equation 2. Therefore, substituting x comma y values in equation 1. In equation 1, that is A into AB minus C square by AC minus B square and plus B into BC minus A square by AC minus B square plus C is equal to 0. Plus C is equal to 0. Then if I take LCM, then A into AB minus C square plus B into BC minus A square plus, as this, for these two terms we have a same denominator. So C into AC minus B square, it is equal to 0. It is equal to 0. Now multiplying A inside, what will get? A. So we have solved BC, CA, AB, BC. Sorry. Here we have taken equation 3 and equation 2. So, solving equation 1 and 2, we got what? BC, CA, BC, CA, BC, CA, AB and BC. So x is equal to AB minus C square by AC minus B square and y is equal to BC minus A square by AC minus B square. AC minus B square. We are substituting that in equation 3, not in equation 1. We need to substitute that in equation 3. We have solved equation 1 and 2 and we need to substitute that value in equation 3. That is C into X plus A into Y plus B is equal to 0 plus B is equal to 0. Then C into AB minus C square plus A into BC minus A square plus B into AC minus B square is equal to 0. Then if I multiply C inside, I'll get ABC minus C cube. A inside, then ABC minus A cube. If B inside, then ABC minus B cube is equal to 0. That is, we are getting ABC and ABC. If we add that C, we'll get CABC. If I send the other terms to that side, to the other side, the terms which are remain, that is A cube plus B cube plus C cube. So this is what they have asked us to prove. What they have required us to prove, this is the one. So we have proved that. What we have taken, out of 3 equations, we have taken 2 equations and we have solved and we have found the point of intersection of these 2 lines and we are substituting that point of intersection in the third line so that we are getting this condition. So we are getting this condition. So this is the other example we had. So you need to do in exercise 3C, first bit, third problem, fourth problem, first bit, third problem, fourth one, fifth one, and in second bit, seventh one, and in second bit, seventh one. So this is your homework. In first bit you have to do 3, 4, 5, and second bit, that is the 7th problem. You need to find the value of P here. You need to find the value of K. Unknown values you need to find. So and the next example we had is a variable straight line drawing to a point of intersection of these 2 lines. What are the lines? X by A plus Y by B is equal to 1 and X by B plus Y by A is equal to 1. So what you remember when you have seen these lines? What you have remember? Do you remember anything? We have proved it already. What is the point of intersection of these 2 lines? Point of intersection of these 2 lines is point of intersection of equation 1 and 2 is what? AB by, already we have proved it, AB by A plus B and AB by A plus B. There we have taken X naught is equal to Y naught in that problem. So the point of intersection is this one. And what they are asking, meet the coordinate axis at A and B. So that the locus of the midpoint of AB is what we need to show that 2 times of A plus B xy is equal to AB x plus y. What they have given more? This straight line, the required line is intersecting the x-axis and the y-axis. It is intersecting the x-axis and the y-axis. And we are taking the midpoint as x naught comma y naught, x naught comma y naught. Then the midpoint, then coordinate A is given by A, x-intercept, that is, if we apply the midpoint formula, that is midpoint. So how can I get midpoint? We have a point A is equal to A comma 0 and B is equal to 0 comma P. Let Q be the x naught, y naught be a point on the required line, then we'll get x-intercept as, that is, as it is the midpoint, so A plus 0 x naught is equal to A plus 0 by 2. This implies what? A is equal to 2 times of x naught and y naught is equal to 0 plus b by 2. This implies what? B is equal to 2 by naught. B is equal to what? 2 by naught. Therefore, as this we have, therefore from intercept form of a line, what will get? 1 by, that is x by 2 x naught plus y by 2 y naught is equal to 1. But the point of intersection of this, in place of x and y, we need to substitute this one, that is AB by A plus B by 2x naught plus AB by A plus B by 2y naught is equal to 1. If I take this common, then 1 by 2x naught plus 1 by 2y naught into AB by A plus B is equal to 1. Is equal to 1. If I solve this equation, if we simplify this, what will get? 2y naught plus 2x naught. 2y naught plus 2x naught by 2x naught y naught. That is, here will not get, as 2 is common, we are writing 2x naught y naught. Y naught plus x naught into AB by A plus B is equal to 1. The LCM over here is 2x naught y naught. The LCM is 2x naught y naught. Therefore, what will get, if I take this whole terms over here, then what will get? That is x naught plus y naught into AB is equal to A plus B into 2A plus B into x naught y naught. Instead of x naught y naught, if we write xy, then x plus y into AB is equal to 2 times of A plus B into xi. This is the required thing what they have asked us to prove. They have given 2 lines and they are asking us that there is a midpoint passing to that point. We need to find the equation of the line to that point. Therefore, we are finding the point of intersection of these two, as we have done already. We are writing 8. That is AB by A plus B is the point of intersection of these two lines, and Q is the midpoint. Therefore, from this line is passing through the intercept. So from this we can find x intercept as 2 naught and y intercept as 2y naught. By the intercept form of a line, this line can be x by 2 x naught plus y by 2 y naught is equal to 1. So in place of x and y, the point of intersection we need to substitute. If we substitute that, we will get this one. So this is another example we have. So next what they have given exercise. Next they have given us sum also. What is that? That they have given a more example. A, B, C are in arithmetic progression. Then show that the equation represents the family of concurrent lines and find the point of concurrency. What they have said? A, B, C are in arithmetic progression. We know when they are in arithmetic progression, we can give it by 2b is equal to A plus C. 2b is equal to what? A plus C. 2b is equal to A plus C. If we frame this in the general form, that is A minus 2b plus C is equal to 0. If we compare it with the general form, that is general form is AX plus BY plus C is equal to 0. So instead of A, X is equal to 1, and from this, by comparison, what I will get? By comparison, what we will get that x is equal to 1 and y is equal to minus 2. Therefore, we can say that this passes through this AB. The equation passes through 1 comma minus 2 is a fixed point and it is a family of concurrent lines. Therefore, we can say that is a fixed point. All the lines, this is a family of concurrent lines and it passes through a fixed point 1 comma minus 2. 1 comma minus 2. So similar kind of problem you have in your exercise also. Similar kind of problem you have in your exercise. That is 10. Hello? 10th one.
Madam, kindly close the session, madam.
Okay. In exercise 3C, second bit, 10th problem, that is in harmonic progression, and ninth one. 9th and 10th. 9th and 10th, you have this kind of problem. So you need to complete these, complete this. Whatever I have assigned before and now you have to complete these. So thank you. Here ends our class.
Oh, thank you, madam.
Thank you.